Hi everyone, we're going to graph y equals ln of x and find this information about this, so you might want to write this down because I'm just going to discuss it on the graph. The main thing about graphing logs or ln's, logs or ln's is you first have to graph the exponent, and this is the inverse of e to the x. So I went ahead and plotted e to the x, which we already did I already did a video on it. Then to graph ln of x, which is the function we want, I switched the x and the y's. All right, and it looks like a lot like log, but not as, limiting, because that was 10 to the x. So basically, when you graph this, we're going to have this kind of, let's see, what is 0.37 goes to -1, goes about there, and 2.37 is very close to 3, but a little over, and that goes up to here. So it's kind of like this. All logs look the same. Okay, it has a vertical asymptote at x equals 0. Domain is x is greater than 0, and the range is all real numbers. Okay, it does have a 0 here. The x-intercept is at 1, 0. There's no symmetry, so it's neither even or odd, nor odd. And then what else do we have to do? Okay, where's y positive? Y is positive here in quadrant 1, so that's from 1. Y, let me get a different color. Y is positive from 1 to infinity, and y is negative from 1 or 0 to 1, because we're looking at the x values. Every time they're asking for that, when they're asking for the interval, they're asking on the x axis. All right. Oops. All right. Now, we have to talk about the end behavior. This is what's going on with this right here. So as y, or f of x, approaches infinity, your x is going to infinity. And here, as y approaches negative infinity, your x approaches 0. So we're getting to 0 because it can't be over here. All right, and it's not 1-to-1. Oh, it is 1-to-1. So we can find the inverse. And the inverse is just y equals e to the x. Let me go back. So the inverse of it is just y equals e to the x. So I'm just going to graph those points there. And maybe I'll just do it on, no, I'll do it on the next one. So if I graph y equals e to the x, that's close to 3. Here's the inverse. All right, so that's f inverse. And our original was here. Oh my goodness. All right. So my inverse is here. Get close to 3 goes to 1. So that's your regular function, and it should reflect over the y equals x. All inverses reflect over y equals x. All right. Now we have to do the transformations of this, and the way that works is it's going to be written as y equals ln of x minus h plus k. So let me graph just the parent function again. Okay, so there it is. Something like that. And the first thing we're going to do is a horizontal shift. And let's go to the left by 3, which would be y equals ln of x plus 3. So we go to the left. I'm just moving these coordinates over 1, 2, 3. That means I have a vertical. Remember that we had a vertical asymptote at x equals 0. So now we're going to have it at negative 3. I'll move this over 3. This goes over 3, down. This goes over 3. And this point goes over 3. So it's something like that. Let me do it in green. So we shifted the whole thing over to the left by 3. That's a horizontal shift to the left. And let's shift this up. And to do a vertical shift up, let's just do up by 4. Let's be creative. Go by 4. So I'm going to take my original and go up by 4. So 1, 2, 3, 4. And this just goes up by 4. 2, 3, 4. And this one goes up by 4. 1, 2, 3, 4. So it just got shifted up by 4. It's a vertical shift. When we shifted it to the right, so let's go back to this piece, the domain changed. Before, the domain was x is greater than 0. But when we shifted it over, now the domain is x is greater than negative 3. And the range stayed the same because it was all real numbers. Okay, that's all of this one. The next one's going to be logarithmic functions with a base of 2, and then we'll do one with 1/2. Thank you and have a nice day. Bye-bye.